Hi, my name is Spacek. I'm in Florida, and the building behind me, that's Foundation for Applied Molecular Evolution. That's where I work. I work here on two projects. One is with MIT. We are trying to figure out why the Venus cloud appears a little bit yellowish. I predict that Venus cloud appear a little bit yellow because of complex organics dissolved in the aerosols of the cloud. The probe testing this hypothesis will be delivered to Venus in 2025 by Rocket Lab. Note that this will be the first interplanetary mission ever flown, and we are already planning 2 other missions to the Venus clouds. The project I'm going to focus on in this video is aimed on Mars. I want to know if there's life on Mars before we first send humans there. The more we know about extremophile life here on Earth and conditions on Mars, the more we are convinced that there could be life on Mars. But we will not be 100% sure until we actually find it there. Despite that, no government agency has currently robots on Mars with a capability to find life in there. What's worse, they are not even planning to find life in there. Well, since NASA is not doing it, I took an inspiration from our mission to Venus and decided to do a private search for life on Mars. I've put together a group with a goal to seriously look for life on Mars. We are not just looking for signs of past habitability, we are looking for life living currently on Mars. Our group is called ALFA Mars. It is spelled with F because it stands for Agnostic Life Finding Association. We are an international group of astrobiologists, scientists and engineers with a support from the Mars Society. I've started this group in 2022 and we are still actively growing. If you believe that we should look for life on Mars and have a relevant expertise and would like to volunteer your time, please contact us. We need to do a lot of work to make this happen in time. All help, such as sharing this video, is welcomed. Well now, how do you seriously look for active biosphere on Mars? First of all, we don't propose to send an additional mission. No, we propose to send an instrument that's going to be an add-on to the missions that are guaranteed to fly to Mars before the first humans arrive. Spacek and other groups that plan to send humans to Mars must mine large quantities of Martian water to make a propellant for the return rockets and to generate the resources for the future astronauts. To refuel a Starship, you will need hundreds of tons of Martian ice. It was found that Mars has huge deposits of thick subsurface ice in mid-latitudes. This mid-latitude subsurface ice is geologically young and was deposited as layers of dust and ice. This means it will contain material swept from the entire surface of Mars. If there was life anywhere on the Martian surface in the recent past, it will be now deposited in the ice that we must mine to prepare for the future human arrival. We propose to extract, concentrate and analyze genetic molecules from up to hundreds of tons of this ice. The genetic molecules are the only agnostic biosignatures. I will explain why all genetic molecules must be polyelectrolytes in a later video. The model you see here is very simplified. It shows only the movement of electrolytes coming from the Martian water. There is, of course, a lot of secret sauce provided by the Electrochemistry and Material Science Lab from the University of Oregon. But the basic principles are shown here. The mine water flows to this channel. It is treated by high-intensity ultrasound, which disrupts alien life structures, releasing their genetic molecules to expose them to electric field. The electric field separates the molecules by charge, with the anions moving towards anode and cations moving towards cathode. The ions pass through size exclusion membranes, and since the large charged biopolymers are unable to pass through the second set of the membranes, they are retained in channel 3 and 5. From there, we pump them to analyzers. Some are analyzed in situ, rest is frozen and sent to Earth for future analysis. Membrane electrodialysis is routinely used in industry to separate biomolecules from tons of material. The accumulated knowledge from the industry and our preliminary experiments make us confident that this method can extract genetic material including alien ones, from tons of Martian ice. And that's it. This simple machine add-on to the mission that must be done before we send humans to Mars is the serious way how to find life on Mars. ALFA Mars plans to provide this machine to everyone planning to mine water on Mars. The incentive is clear. The team to first mine Martian water on an industrial scale can be, thanks to ALFA Mars, the first team to find alien life. I want to make this point clear. I applaud NASA for the Artemis program. I believe that human curiosity and presence should extend beyond the lower Earth orbit. I am glad to see that humans are returning to the Moon and plan to go to Mars. I am grateful for the discoveries NASA has made on Mars so far. The results they provided convince the world that life is possible on Mars today. I just believe that now it's time to make the last step and to look for life on Mars. Ideally, before humans get there. If we cannot do this research with NASA, ALFA Mars is ready to do this with public support. We have started a media outreach campaign and we are looking for investors to help us look for the alien life. With Mars Society, we plan to send our students to Mars analog mission in high Arctic this summer to test the first prototypes of our instrument and to raise awareness about this issue. If you share our goal, please consider supporting us. Your money will be used to advance development of our instrument and to support the mission to Arctic. Well, that's it. Check the links in the description below the video and let's find life on Mars.